So today we're going to talk about bisectors of triangles. That means angles, perpendicular bisectors, all different kinds. And some vocabulary you're going to need to know. First is concurrent. Concurrent means that three lines are intersecting. So if two lines cross, it's called intersecting. If three lines cross, it's called concurrent. Okay? So the point of concurrency is the point where the three lines intersect. So, for instance, in these three lines, that point right there would be the point of concurrency. Where's my recording thing? Okay, and the circumcenter in a triangle is the point of concurrency of all the perpendicular bisectors. So, what I did here was I drew the perpendicular bisectors. There's these pink lines here. Okay, so that is a perpendicular bisector, perpendicular bisector, perpendicular bisector. And their point of concurrency is out here. Okay, now in an obtuse triangle, it'll always be outside the triangle. In an acute triangle, it'll always be inside. And in a right triangle, it'll always be exactly on the hypotenuse. Okay, and the nice thing, the couple characteristics of a point of concurrency when you have perpendicular bisectors. So if the circumcenter of a circle is that the distance from the center, this point of concurrency here, this circumcenter, to each of the vertices, so these red lines here, are equal. So from here to there, from here to there, from here to there. That's all equal. Okay? And so when you find the point of concurrency, it's equidistant to each of the three vertices of the triangle. And if you put your protractor right in the point of concurrency, get it right on there, and open up your protractor, or your compass, sorry, to that exact position here. A little too far, I don't know if I did it exactly. And you draw a circle. We say that circumscribes the circle. It's a circle that goes around the outside, and you'll notice it hits exactly the vertices of the triangle. Okay, and that kind of makes sense because if that's the center of the circle, and so the distance from here to here, that's a radius. So it makes sense that a circle would exactly touch all three corners of the triangle. And we call that a circumscribed circle, hence the circumcenter. Same thing over here. If I put my compass right at the circumcenter, and I open this up to be right there, and then I draw my circle, it's going to hit the three corners of that triangle perfectly. Okay? Again, that's the center of that circle, the circumcenter. Same thing with the right triangle. If I put my compass at the exact circumcenter and open it up to exactly the corner here and draw, let's see what I can do here. I get them off a little bit. Draw the circle, it will exactly hit the corners of the triangle. All right? So if I were going to mark these, so the perpendicular bisectors are these purple ones right here. So now I can make them red. So here, this is a perpendicular bisector. This is a perpendicular bisector. This would be the circumcenter. And the distance from the circumcenter to H, from the circumcenter to J, and from the circumcenter to G, they're all equal. Okay? So we can use that to solve problems. So here's my my perpendicular bisectors. Okay, so that's my circumcenter. The distance from here to here has got to be the same all the way around. So if this one's 19.9, that means this one's 19.9, and this one's 19.9. And then the same stuff we learned yesterday still applies, and that is this is a perpendicular bisector, so if this is 18.6, then this distance is also 18.6. Let's see what else. And if this distance from here to here is 9.5, that's on a perpendicular bisector, so that doesn't really help me. Except I can make it into a right triangle maybe, but for right now that's it. All right. The incenter theorem is when all the angle bisectors intersect. So up here it was when all the perpendicular bisectors intersect. This is when all the angle bisectors intersect, and it intersects what we call the incenter. Okay? And just like the distances, once you find the incenter, the distance from the incenter perpendicular to the side, okay? No, I didn't do a very good job on this. Is equal. So once I find the incenter, if I draw a line from the incenter to the perpendicular to the sides, they are all equal. Right? And what happens when you find the incenter, if you put your compass here and draw a circle, it does what we call inscribes a circle. Okay? It draws a circle that touches at the 3 points that are perpendicular to the side. Right? So that's why, same thing, these are all radii of that circle, so they're all equal. Right? If I'm going to find the perpendicular bisector of, all right, if I'm going to try to find the circumcenter of this graphed triangle, remember the circumcenter is made of perpendicular bisectors. So perpendicular to this vertical line is going to be horizontal, and bisector, if it's 1, 2, 3, 4, 5, 6 tall, then 3 would be halfway. So my first perpendicular bisector is going to be there. Okay, this one's horizontal, so I could have a vertical, and it's 1, 2, 3, 4 long, so 2 would be halfway. So this is my another perpendicular bisector. And then the third one, I got to find the slope of this line, which is at 0, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 0. So to find the slope, I would do 0 minus 6 over 4 minus 0, which is negative 6 over 4, or negative 3 halves. So the perpendicular slope would be positive 2/3. I need to find the pinpoint, so 4 plus 0 divided by 2 is 2, and 6 plus 0 divided by 2 is 3. So my midpoint is at 1, 2, 1, 2, 3, right there. And my slope is negative 3 over 2, or no, positive 2 over 3. So I would go up 2 over 3, down 2, left 3. So my third line would go through there. All right, and there would be my circumcenter. If I calculated the distance from here to here, from here to there, and from there to there, they'd all be the same. If I put a compass in the center here and do a circle, it would exactly outline that circle or that triangle. Okay? All right, so if you would like to try this one, go ahead. And then last but not least, I would like you to answer these questions on a sheet of paper and be ready to turn them in to class tomorrow. So here's 1 and 2, which you can stop and work. And here are 3 and 4. All right. Good job today, guys.